I am audible. Hello. Yes. Okay. So last class we discussed about basic instructions, right? Basic instruction, timer, counter, comparison, and all those things, right? So today we have to see with some assignment basic related things. Okay? So because we have to generate a value from 0 to 100 and 100 to 0 like that. So for example, if you generate value from 0 to 100 and 100 to 0. So like that you have to generate a value continuously. So once if you press the start button, press the start button, this process will be continuously how to do it. Like so once you press the stop button, the process will be stopped. Like that you develop a project. Okay. So already you know the timer, right? All 5 timers I explained. Counter also explained. Count up I explained. Count down I will show you today. Okay. Count down and count up and down. Then we will go for the generate the value. Then you see if that value is considered as a level or anything. So if you go to greater or equal to 50, greater than 50, mixture is on. Then if you go to above 80, valve is open and mixture is on. Like that you have to make it. Okay. So there is a comparison. Assume that that will be considered as a level sensor. It will be goes to 0 to 100. So based on the level sensor, you have to start. Okay. Above 50 and below 80, the mixture is open on. Okay, so like that. And the valve is open close also like this. Here. Then the input goes to greater than 50, mixture on. Input goes to greater than 80, valve is open. Okay. And how many times the valve is open goes, then how many times mixture is on and valve is open goes, that also you have to count it. So because the maintenance is in the right, so that is the problem. Okay, so then you have to generate a blink output. Okay, these are the 5 experiments, 4 experiments we have to do it. So the third experiment generate a value from 0 to 100. Then 100 to 0, like that it will continuously it will be do it. Then one mixer is there, assume that one mixer. That mixer will be on, it goes to greater than or equal to 50. Then valve is there, okay. There is a tank level, the valve, the solenoid valve, okay. Solenoid valve. The solenoid valve goes to above 80, this is open. So then that mixer and valve will be open close separately, you have to count it because for example this valve will be open in the practical as a 2000 times or 3000 times open close, then maintenance is needed, right? So that is they are putting for one indicator. The valve is open more than 2000 times, then indicator will be on. So that is alarm purpose. So like that the mixer may be running with this many hours, how many times open on close. Okay. So that time also you can count this one. So that is the purpose. You can put the indicators. Right? That's the thing. So now I will share the screen once again. Okay, share the screen. So last class, any doubt is there? Last class. Any doubt? No doubt. Okay. So here step 7 software, you must concentrate the addressing. Okay. So the addressing you know. Starting from M is a memory, B means it's a byte, okay, MB0 means, next if you want word means you go to MW, okay, MW1. So then MW1 contains MB1, MB1 and MB.
When?
After finish this container, come here, finish this container.
That's all. MB.
Ciao. نشيل التيب ونشيل التيب عندنا فوقيها.
D.
أنا شيل. تدفع 20 10 10 5 ريحة بالنسبة لي. عشرة
Hello. Now it's okay.
عشرة أنا عشرة 15.
Now screen sharing is okay, sir. Please. Screen sharing okay? Yes.
semua macam
Sedap. Correct. And see
sedap.
addressing. Okay, Siemens step 7 addressing step 7 PLC.
Pasal bagian
Okay. So M. Yeah. No, sir.
That's all it's okay.
Screen sharing is not okay.
It's okay, it's not okay.
Screen sharing.
Now
I
that-
take only notepad. This
Then yes.
notepad. Okay or not?
There are computers on that.
What is the problem?
This is my screen.
Maybe you need problem.
Somnath, Sridhar. Still problem?
Another it is good. Very normal.
Oh, Abhishek
What
okay.
do you- how many
Abhishek ji and
I still now I check all carton.
Dahar
What
also
carton?
All carton.
Mohammed Hasan.
Carton already check.
Somnath Roy.
What like this?
Not getting. Screen sharing not working. I am hearing. No, the screen sharing. Start button. Now I click the start button. So what's the problem? Oh, okay, right? Screen sharing okay. Siva, Praveen, Muhammad Yasin.
To do, only I will see. Not okay.
It's okay, right?
But
So
I
then
will
you can
communicate
check
on
out.
that.
So then you can leave and once again you can join it, G. So those who are, I think, network
I don't
issue.
know more problem.
No problem. Network issue
Yes
means
problem.
No.
Maximum problem.
Use okay.
all others are getting, okay?
Open use. See, remove okay and use it. It's not going. This is a problem.
But I saw no clear. Too much pressure and then like that and then after.
Still
I
problem
get-
is there.
Avoid this problem from this one only. Take okay when which is going inside. Okay when take it and put inside. If from okay when not going,
Please
this
check.
this problem.
Okay.
One
I-
second.
But if it is going, this means somebody problem.
Payments.
You get a problem. Line up problem maybe.
At the model problem.
Line up.
At the represent the model problem.
Line up.
I don't know. Like
Yeah, don't say item.
Same
Use the
problem
scale.
is there.
Which is going, this is going, all going.
Somebody-
Which I think not okay, is going. Okay when
Siva,
say
Praveen, okay. So class, no problem. Yes. Then what's the problem? Somebody is, sir, I rejoined, but still is.
sir.
somebody go.
So what to do? Rejoin, but still issue is there. Whether I leave and once again I join, try to the recording.
Baznya.
Okay.
Siapa? Saya.
Somnath is having problem. No problem. Mohammed case no problem, right? Shivaji okay, then Yasin okay. So only Somnath is the problem, right? Morning at the heart. Yes. Praveen. Still problem is there. Stop sharing. So here raining is going on. Select screen. Button. Hello. Yes. Now okay. I put it. Not bad. What happened today? Okay, I think so now, right? Step 7. What are we are discussing? MB, right? MB 0, then MW1, then MW2. MW2 is not there, right? No, MW2. Next is MW3 only. Right? MW3. MW1 it contains MB1 and MB2, right? MB2 is there. Then here MB3 and MB4. Like that, if you go to MD, it's a double word. So normally if you are using for the floating point, then you have to use for the MD, double word, right? Double word. So that it's contained, what are things? MD, here 4, 5. MD5. This MD5, you are having MB5, 6, 7 and 8. So total 4 bytes are needed, right? 4 bytes. Okay, like that it is. Okay. So this is a thing, this you have to must follow the rules. For the 300 and 400 series controllers, if you are using for step 7, that is mandatory. Otherwise, sometimes it will be so as a herbage value. Actually, the PLC will be working, you are not able to the correct data. Herbage value only working. Okay, so that's very careful. Now in this case, we are using for the step 7 software. This is select. Software Siemens. So I'll show the hardware, okay? With the TA software I'll show it. Siemens automation, right? Sensimatic manager. Okay. So in our case, what we are doing means first step, the project is, for example, now this is your RTU. Now this RTU we are using for Siemens controller, right? Siemens controller. Then from this RTU, we will connect to the field instrument, right? Field instrument. These field instruments will be collecting the data or controlling the plant. Okay. So then it's communication. So using the communication protocol. Okay, communication standard Ethernet protocols or Profibus or Modbus. Then it will be connected to your MTU system. Okay. This is called a MTU, Master Terminal Unit. Okay, MTU, Master Terminal Unit. So here you can load some software. That software is called a OPC server. Okay, OPC server. That anyway we discuss. Don't worry. Okay, OPC server or OPC EUA. This is the SCADA part. This is the SCADA station. SCADA you have to load. Then you have to make a screen, trending, all those things you have to make. Trend screen. Then if you want, you can store the data in the database. This is your commercial database. Then if you want, you can push the data. So instead of storing the database, you can push the data to internet. Okay, internet. The IoT concept, okay, IIoT, industrial topic. So whether if you want it directly, also you can send the cloud. Some of the RTUs or field instruments are available. Otherwise, you can send the data through RT also, it's possible. Okay, so that also we will discuss. Now we are doing the programming here. After that, we will go to the SCADA side. After that, we will go for the IoT things. Understood? This is the way we are going to process. So then, your practicing purpose, we will with the simulator generating the value. So that's why we are giving that assignment. You generate a value from 0 to 100. Okay, 0 to 100 you generate a value. Then after that you can generate a value from 100 to 0 also. That it will be continuously how to do it. So that is the experiment we are doing. So that how to do it. You see, this is our software. Cancel it. Okay, cancel. Then this will come to like this. This is our last project. Okay, last project. Better you can use the last project, or if you want, you can create a new project. Okay, new 3. Select new project 3. Then just right click. Then add the controller. Okay, PLC. Then we can expand this hardware. This hardware configuration area 300 series. We go to 300 series, right? Then first you can add the rack. Okay, expand this rack. Then double click. So all the PLC you are having them each rack in the Siemens controller, each rack 400 and 300 series, 300 and 400 series, 11 rack. Okay, 11 slot rack. Okay, not slot. This is the slot. See, first slot to 11 slot. First slot always power supply, or you can give as a empty, because empty means external power supply, you can use it. Second, always you have to put it for the CPU, for the first slot. That means it's counting from 0. Okay. Then third is interface module or empty. So because if you go to more than 8 IO cards, we need a interface module. Otherwise, less than 8 module, then you can less than or equal to 8 module, only one track is enough, right? So then you can no need for the interface module. So that's the thing. In our case, we are using for 300 CPU, 314 we are using. Okay, 314 controller we are using. 1200 series I showed you. Okay, 1200 is another series. So 300 series already explained. 300 series is there, 400 series is there, then 1200, then 1500 is there. So the 1500 is the latest one. 1200 and 1500 will support for only TIA software, total integration automation software. That is the next version of step 7. Okay, step 7 software. You can configure, and there also simulator everything are available. So that also that's the thing. Select
माफी मालूम वो
4, double click, save and compile. Okay, save and compile. Don't forget, not only save it, save and compile. Right. Now go to the project, expand like this. Okay, this is the P1. Now, as per our project, okay, as per our
Nitrogen, huh?
generate a value between 0 to 100, right? Every 500 millisecond.
Hello?
Now you see that is.
Yeah, your nitrogen coming.
Just a minute, I have to download the. Here that already upload this
Just a minute,
data, okay?
the
PLC
person is coming.
PLC assignment.
इधर ही wait करो, इधर ही अपेक्षा करो. Oh, बंदा coming.
Okay. And I put it to my folder. Right, double click. Now you see all 5 timers okay. Then count up already explained. Count down if you want, I'll show to you. Then this is the value, generate a value. Okay. So that how to do it? You have to add here. You see, just to select every 500 millisecond. Here you see, sample rate every 500 millisecond. We have to give the 1 increment. Okay. That means if you go for 0 to 100, how much time taken? 0 to 100. How much time taken? Already I told, right? 0 to 100. That update rate is 500 millisecond means it will be goes to, this is normally is called a 50 second or, okay, 50 second it will be take, because 1 second 2 increment, right? So then it will go to here. Then again it will goes to here, 0 to 100, then again 50 second. Okay. 1 up and down it will take for 100 second. Okay, so like that. So suppose if you want very fast, then you every 200 millisecond. If you put it for every 200 millisecond, then 1 second 5 increment is there, right? 5 increment is there, like that it is there. The speed we have to update. Understood or not? What I am saying? Got it? Yes or no? Yes. Okay, this is the thing. Now now I select the project here. Just we can put it on start button M0.0, right? M0.0. Then I put it for 1 timer. Select on delay timer. Then output. Just I put output. Timer output. Timer address T0 already you know, right? T0. Then preset value T has S5 T has 500 ms. Right? 500 ms means just a millisecond, right? That is a 500 millisecond. Then we'll go for done bit M1.0 like this. Okay? M1.0. Right. 1.0, save the project. Now what will happen here? If close the switch, after 500 seconds, this will be make it true, right? This will be make it true. That is the on delay timer, right? If you want, you can check it. Save this one and download. Go to the main window. Start simulator. Okay. Start simulator. And select your project. Right click, download to the controller. Enable download, yes, because that you have to check the multi-point interface protocol. Yes, once again you have to download. Select, right click, download. Yes, download. OB1 is started. Now minimize. Okay, monitor. Select. Here we can make a run P mode. It's running. Now you see insert bit memory. Okay, bit memory and insert bit memory. Sorry, MB0 and MB1. Then
Hey, mobile here, Ravi.
switch close.
Mobile here.
Yeah.
Okay.
After 500 milliseconds, the output is on. Suppose if you are not able to see, just I will give to the 5 second. You see, like 5 second. Save the project. Download. Yes, monitor. Now you see symbol. We have to add one switch to here. Here you see assign normally closed switch. That address is this address you have to assign. That's all. That means continuously it will be do. Okay, you see. Go offline. Just I will give to the normally closed switch for this location. That address M1.0. Okay, save the project. Then download and monitor. You see here, very careful how it's working means I'll show to you. Now this switch is closed, right? This switch is closed. This is normally closed switch, right? That means this normally closed switch address. What is the address? This is the address, right? Same address. So because now this is 0, then this signal will be goes to here. If the signal goes to here, the timer starts. What is the timer preset value? It's a 5 second. That means the accumulator value goes to 1, 2, 3, 4, 5. If reach to 5, this is true. This is true, right? After 5 seconds, this is true. Then what will happen? This immediately open. This will be open. This open means again this accumulator value goes to 0. Then output is 0. Then immediately it will be closed. So at the second it's open and immediately closed. That means that process will be continuous. So that's why it will be goes to like this. Actually this output how it's working, you see, I'll tell you. Once this switch is closed, this is starting point, right? Starting point. Then after 5 seconds, it will be generate this 0. Okay, this 0. What is this address? This is M1.0. This is true. Then after that it will be start. Then after 10 seconds, that means after 1 more plus 5, right? 10 seconds, again it will be generated from spike. Then after that it will be generated 15th second. Like that only this will be goes. This is for 15th second. Sorry. This is for 10th second. Okay. 10th second. This is for your 15th second. Like that if we go for 20 second. It will be go to like this every 5 seconds because this is your time delay is 5 seconds. Understood or not? Now this how much time this will be on? This normally it will be one scan cycle. One scan cycle. That scan cycle already you know. One scan cycle means every millisecond or microsecond or nanosecond. That is depends upon the CPU. Okay, so that's the thing. Now this address, okay, this address we are giving to one count up CTU count up. Then that switch we have to assign. Okay, then this count up value is increased 1, 2, 3, 4, 5 like that. Okay, then it will go. If reach to 100, you can compare greater than or equal to compare and reset button. Then you can make a countdown. So that is a logic you have to try to identify. Okay, so I will make it some small idea. Select, right click, insert this one. Here I put it for one count up. Okay, CTU. Count up CTU. Okay, CTU. That address CU. Okay, C0. Okay, count up C0. Then just I assigned this address, same address, m0 point, m1 point, m1.0, okay, m1.0. Then assign the put it on that value, this address. What is the value? MW2. Okay, don't assign 1 because 0 to byte first bit we are used for this switch. 0 byte and first byte and 0th bit again we are using. Then this 2 already used, this 2 bytes. The next byte is free from 2 onwards. Okay, like that. So that's why you have to give like this. Okay, save this one, download, yes, go online. Now you see here, you can see the value. Okay, the increment, close this one. After 5 seconds, 1 increment is there. Yes, you see 1, then 2, 3, 4. Every 5 seconds, 1 increment is there. Suppose instead of every 5 seconds, I put it for every 500 milliseconds, then the data will be updated for very fast. Understood or not? This one. Okay, like this. Now you see I change the preset time, 500 ms. 500 ms I put it, right? Save the project. Now download, yes, and monitor. You see here, start. You see that value is increased. Understood or not? This is a counter value. Here you are displaying the hexadecimal value. Here normally you can display 35, 36 like that. If you want reset, you can press this button, reset, automatically it goes to reset. So that also if you want, you can test it. Go offline. Reset button, M0.1 I assign. Okay, save this one, download. Yes. Okay, this is the thing. And monitor. Now you see I am going to press the reset button. Not this one, sorry. Reset button is M0.1, this address, right? This is the reset button. Now you see, close, reset. Now open, then start. 1, 2, 3, 4 like that. Understood or not? Like this. So here normally value you are getting the normal integer value, then compare the value. Go offline. Okay, compare this value. If you want, you can help, just select the instruction F1. This is the count value. You see, count value, input address, everything is available. Just press F1, all the data you are getting. Okay, that's the value. Then you'll go for comparison, compare the value, automatically you can reset. Right click here, greater than or equal to, comparison already we discussed, right? Greater than or equal to which address? MW2. Then I put it for some 20. Then we have to make a reset option, output address. Then you see M0.1. Now what will happen, you see this value is come to this particular location. This value will be compared with 20. That is true. Then automatically, okay, so that automatically it will be go out to reset. This is true. Then it will be goes. Then what will happen? It will go to 0 to 20. Then again it will be goes to 0 to 20. Like that it will be generated. So now you have to write a program for 0 to 100. That's all. Okay, 100. Now save the project. Just to download and monitor. After this one, you see, select, start. See the value here. Here you can see the value only for 20, right? 20. 0 reach to 20, but what 0 to this maximum value, then maximum value to go to minus value, then again see this. Okay, try to understand concept. You understood, I think so, right? That project you have to do it, because this we can compare to our SCADA. We can generate some SCADA software and how to interface, that I showed you. Okay? That's the thing. Before that, what is SCADA, everything I explained. This basic program is needed to for further project. So for example, maybe you are thinking that, so without this, without counter also, can we do it? Yes, that also is possible. See, that how to do it. I will show to you once again. See, go offline. Without this one, without count up, I want to do the same operation. Yes, that also is possible. How to do it? Right click, insert another operation. You go for mathematical instruction. You see, mathematics, comparison okay, counter okay. You see, mathematical instruction, integer function is there. You see, integer function. You select this integer function. Here addition is there. You see, add double integer. Add underscore I means integer, D means double integer. Okay, just double click this one. Now I put it for one memory location. For example, MW10. Okay, MW10. Okay, MW10. Then add 1. Okay, add 1 is a constant, right? Then I will store to MW10. You see, very careful. MW10 is one memory location. One memory location, integer memory location. This MW10, okay, MW10, the initial value is 0. Initial value is 0, right? Now, after that, execute this instruction, then plus 1 and store to the same memory location. That is very careful. That means this memory location, MW10 will be increased 0, 1, 2, 3, 4. This instruction every scan cycle. Suppose every 500 millisecond means this switch you have to assign. That's also very simple. Logic is very simple. Like that, one problem, so many logics will be there. So now you see M 1.0, right? Check once again the
Maybe go that area.
If close the switch,
Yeah, maybe.
this will be on.
Because of here, no
500
possible to loading.
Like that. Okay, every 500 millisecond. That means this for your 500 millisecond, this for 1 second, then 1.5 second, then 2 second, then 2.5 second. Like that, that increment will be goes, right? This is open close.
Right.
That time, this memory location, it will be increased. 0 plus 1 plus 1
Yeah,
plus
50
1. Like
real,
that,
15 real.
0, 2, 3, 4, like that, it will be increment. We'll check it.
Yesterday you see
Save this
how
one,
much?
save this
Only
one.
5 real. Right.
Download. Okay, save
15
this one, download
1.5.
and monitor. You see, now you see once again.
Huh? No, two more.
1, 2, 3, 4, 5.
Sorry,
like that. Voting.
my mind.
Understood or not?
Colors.
15, 17 like that.
Expired.
Now,
Let's go,
this
let's go.
value
Let's
is
go.
to
It's clear,
100.
Zan,
Again,
it's
you
clear.
hold the value and down. Take one. So minus or count down. You can use it. That's the thing. Okay, so that's I told. So one problem, so many logics will be there. So I will explain how you can do this project instructions. I only explain. Remaining idea, you try to develop something. Okay, you try to do something. Okay, understood or not? This thing. I hope everyone understood. Any confusion or any doubt? No doubt. So now you see count down. Count down how it's working. You go to the counter left side. CD. Okay, CD. You put it for C1. That is a address. Then you put it for another switch. For example, M 0.7. 0.7. Then we put it for some address value. Okay. See, we leave it. Now address PV present value or preset value. Okay. C has 6. Okay, 6 enter. That is a syntax for the counting entry point. Set M1 M0.6. That is a reset and set value. This is the thing. Now save the project. I download. Yes, download. Now monitor. You see here. You see. This is the address. 7th bit, 0th byte and 7th bit, this address. I am using for countdown, very careful. I am using for countdown. Whenever the switch is closed, this will be goes to minus. Now actually my default value is 0, right? Now I press the switch, what will happen? You see? Nothing will happen because in this case, no minus count, no minus packet, right? So counter means normally used for the up. Or the value from the x value you have to make a decrement. That x value is 0. Up to 0 only it will be decrement. So below this one it will not go. If you go for some other PLC, simple example, if you go for Allen Bradley PLC, they are doing minus count also. But here the minus decrement will be goes to up to 0 only in the case of counter. So then how to do it? This operation countdown, then you see this is the set switch. Once press the set switch, this value, this accumulator, not accumulator, the preset value, PV, preset value loading to this accumulator value. You see, just I press the button, 6th button, you see, this is the value. And now maybe you are thinking that, sir, what will happen? Here actually is a 6, right? Now it's loaded to store. What is the problem means? If loading the value and he will be minusing 1 also because this is the countdown. So within the fraction of second, immediately he will be load the value to particular one and he minus 1. So that's the thing. So next time if you open close, you see next time if you open close, what will happen? The 7th bit is open. Now I close, it will go to 4. Then you see 3, 2, 1 and it's reached to here 0. Below 0 it will not go in the case of Siemens countdown. Okay. So Siemens countdown, Siemens PLC countdown operation up to he will be doing with the countdown 0 value only accumulator. Below 0 it will not go. Okay, some other PLC may be working, so don't compare that PLC and this PLC. Right? Understood or not? Right. So if whenever you are using the countdown in this case of Siemens, you have to use for the set switch. Using the set switch, you have to load some value to the accumulator. Okay. From the accumulator value, you have to make a countdown. So that is called a countdown. Next one instruction, count up down is there. You see, CU, CD and next one is CUD. Count up and count down mixed one. That means C2, counter 2. Now here the instruction count up switch, count down switch, set switch, preset value, reset switch, then accumulator value. That's all. Accumulator value display in the two format. In this case, it's a normal format and BCD format also. Okay, so normal format, BCD format. Now count up switch. Okay, I put it for another switch. Here M 0.3. I put it. Okay, 0.3. Count up switch. 0.3. Yes. Okay. Countdown switch. M 0.4. Okay. M0.4, right. Okay. Set switch. M 0.5. Right. Preset value C has 5. Okay, that is a preset value. Then okay, so then if you want you can output, you can assign or leave it. Now you see count up down. Okay, save the project, download, yes, monitor. Now very careful, you come to the PLC here, simulation. This is your count up switch. bit number 3. Okay, countdown switch, this red color, okay, this red color, this countdown switch is 0, 4. Countdown switch, right? Set switch is a 5. Okay, anyway, these two only we are checking now. You see, whenever I press this button, it's an increment. Whenever I press this button, it will be decrement. That's the thing. Up, down, count. Okay, this one you see. Understood or not? This now to 0. Now you see, once again you press, it will go to like this. 5, 6, 7, 8, 9, like this it will go. Understood or not? Then if you press the load switch, okay, set switch, the set switch, then 6 will be loading. Here you see this one. C5. Okay, C5. Why it's made true? Because here that button is always on. So that's why it will be true. Now I press the button, you see, load switch, S5, load switch, it will go to load the value to 5 here. Okay, that is the thing. So both mix of count up and count down, it will be called as a count up down counter. So then your project you have to generate a value you can use for the count up down also. So I explained up, down, and timer and comparison, everything I explained. So you can use the all instruction and try to the project to like this, 0 to 100 like this. Okay, this you try to do it. 0 to 100 you don't need, otherwise 0 to 50 also you can do it. Okay, no problem. 0 to 50 and again 0, then again 0 to 50, like that you try to do. Okay, program, once you do this one, is understood all the concept, basic concept. I hope you understood, right? I hope you understood. So this project I explained, 5 timers and 3 counters explained. Then this is I am going to be explained. Any doubts or any doubt? Any doubts? No doubt. Right? No doubt. Okay. So now next, if you for blinking section means suppose this is a memory concept. This is a very good experiment for the understanding the memory concept. This memory, how it will be stored, you see, already I told this for example MW4, tell me, MW4 means what are the bytes are there? What are the bytes, please? Try to do it, no problem. Just to tell me, what are the bytes? BCD, what is a BCD purpose means if you go to a 7-segment display, for example, if you go to airport and railway station, they put it for a 7-segment display, right? Like this, 7-segment display. In that 7-segment display, they have to use to only for the BCD format, not normal format. Then only you are able to display. Okay, that is a BCD to integer or integer to BCD only we are able to convert and do it. Okay, so that one separate class is that I will tell you. Okay, don't worry, I will tell you. So normal 7-segment it will not display for this case. Okay, you have to convert. For example, if you want to display to 62. That 62 you have to convert it to the BCD format, then only you are able to send to the 7-segment display. Otherwise that data will be display will not correct. Okay, that's the issue. Okay, that's why BCD, binary code. Right. Now my question is MW4, right? I am putting for MW4 or MW3. Okay, MW4. This MW4, what are the bytes are there? Sridharji, MW4, what are the bytes? What are the bytes? MW4, it's correct, Sridharji? MW4, what are the bytes are it contains? What are the bytes? Yes. MB. Okay, MB4 and MB5. No doubt. I hope you understood, right? MB4 and MB5. Right or wrong? So because here always it will be starting address only. Okay, starting address. That means never forget byte means single byte, only one jump. Byte. Word means is a double jump. Okay. Double word means it's a 4 jump. That's all. So this is a 4 jump, 4 increment. Okay. 1 increment for byte, 2 increment for word, 4 increment for by double word. Okay, that's the thing. Now this data, how it will be stored? This data will be stored. It will be like this. Already I showed a slide. The slides also it's available. You see, this will be stored like this. This is called a MB4. MB4. This is MB5. Okay, this most significant byte. Left side is the most significant byte. Right side is the most least significant byte. Right? Okay. Next question. Each byte. How many bits are there? Tell me. Each byte. Each byte. How many bits? 8 bit. Okay, simple. 8 bit. Like this. Okay. This it will be like that. Very careful. This is a little bit interesting also. Then this is 0th bit, right? 0th bit, first bit, second bit, third bit, then last is 7th bit. Understood or not? Then this fellow also having like this. Like this. Here also is having the 8 bit. It will be like this. I hope understood. Any confusion you ask me, okay? This 1, 2, 3, then again it will be goes to 4, 5, 6. 4, 5, 6 and 7. Okay, 7. Okay. Then here also 4, 5, 6 and 7. Understood or not? No doubt. Now my question is, what is this address, this particular bit address? Tell me, what is the bit address? What is the bit address? You are able to see the screen? Yes. What is the bit address? This address. This is called a... No. Imamji, yeah. What is the address of this one? M. You press, okay. You press shift key, I think so. M. No, not MB. Not MBG. Imam and Shivaji. Very good. You have to give this address. Okay, this address actually is a M. Just enter the byte address and bit address. That's all. Got it? Not B. So if you are asking to this enter byte, you are using for MB. Now this is a single bit, right? That single bit you have to enter like this. Now tell me this address, last address of this one, M 5.7, very good, 5.7, right, 5.7. Then tell me the next address, this address, tell me this address, what is the address, this one, tell me. M, I hope you understood, M. Yeah, 4.0, very good. It's M 4.0. Good. M 4.0. Like this is the M 4.7. M 4.7. I hope you understood, right? Then, for example, here, this is called the one word. What is the word address? Is a MB4. Yeah, MW4. This is MW4, right? MW4. Now I store one value. To this particular memory location. So for example, first value is 0. First serial means all the values 0, 0, 0, 0, 0, 0, last everything is 0, right? Then I want to store 1. 1 means it will be goes to 0, 0, 0, 0, last is 1, right? Last is 1. Then next is 1, 0, like that. That means that value, here how the value will be stored, all 0, 0, 0, 0, 0, 0. Then next is 0, 1, right? Another thing is you go for 1, 0. Then next is 1, 1. Then next is 1, 0, 0. Like that it will be stored. I hope you understood, right? This is 0, this 1, this is 2, this is 3, and this is 4. Like that it will be increment. Understood or not? Got it or not? This is the way the data will be stored. This is the way the data will be stored, right? Now I will make somewhat clear picture. This we have to make it clear. Now you see this area, okay, this area I want to store some value. Starting value is 0, then 0 0 0 0 0 0 0 0 0 0. Next value you go to 0 0 0 0 0 0 1. Next value 0 0 0 0 1 0. Next value 1 1. Next value 1 0 0. Next value 0 1. Next value 1
كثير أنا تعمل جيد
0.
بالتالي
These for 1,
أنا أدري أنا ما
these
أدري
for 2,
أنا
these for 3, these for 4, these for 5, these for 6. Like that it will go close to maximum how much value? Tell me. Maximum. Here 0 to 7. Here 0 to 7. Only positive value maximum. Tell me. Maximum. Whether is someone how many? FFF. Not FF. Only 2F or 4F. 4F. Very good. It's a 4F. In the point of view, integer value. What is the integer value? That is the maximum value you are storing. That means
Now the generator
you
কাজ করতেছে
are using for the data means it's an unsigned integer because total 16 bit. Total 16 bit is a one
জেনারেটর
bit,
ওখানে
right?
কাজ করতেছে
Then
জেনারেটর
here
ওখানে
8 bit, here 8 bit.
কেমিক্যাল প্ল্যান্টে যে জেনারেটর আছে না ওখানে
It's unsigned integer maximum value. Unsigned integer.
মানে এখন তো যে ফিলিপিনোরা আসছে ওদের সাথে কাজ করতেছে পরে হলে হবে না
Maximum how many bits?
আমার মনে চলে যাবে একটু পরে মানে তাহলে পরে কল দিন
Maximum how many bits for this particular word?
হ্যাঁ
Word means how many bits are? 2 power 16 minus 1.
ওকে সমস্যা নাই চেক তো করতেই পারবে সমস্যা নাই
Here 8 bits.
কিন্তু যে এখন জেনারেটর কাজ করতেছে তো
Understood
একটু
or
পরে
not?
যেতে
What I
হবে
am saying you understood or not?
ওকে
Yes or no? Yes. Now, what is the value? 2 power 60 minus 1 is maybe 65,535. You want, I will take a calculator and show it to you. See? Calculator. See. 2 power 16 minus 1. 65,535, correct? Then this value is going to increase up to 65,500 and this value goes to increase, right? Increase up to 65,535. That means all the bits are 1 1 1 1 1 1 then 16 ones. That will equal to this one. If you want that also you can check it. This is 65,000. Scientific programmer calculator 65,535. That is the binary value. You see, this is the value you are getting. Understood or not? Yes or no? Yes. Got it? Right? Now you see, then the data will be stored. Once again I stored 0 0 0 like that. It will last bit times that is 0. That value is 0. Then next is 1. That means this is the 1. Integer value is 1. Okay. Then next is 1 0. That is for 2. Next is 1 1. That is for 3. Next is 1 0 0. It's a 4. Okay. Last value is 1 1 1 1 1 1 1 1 then 1 1 1 1 like that. This value is 65,535. That's all. Got it or not? Now you can carefully watch in this location. this location. What is this address? What is this address actually? What is this address? Tell me. It's a MW4. Already I told MW4. MW4 means it contains MB4, MB4 and MB5. Right, MB4 and MB5. What is this address? Tell me, what is this address? Last address. This address. Very good. M5.0. M5.0. Next, this address. Tell me, next bit address. What is the address? What is the address? M 5.1. 5.1. Understood or not? This is the thing. This last bit address, tell me, what is the last bit address? M 4.7. Very good, yeah. You people are very strong, I think. Very interesting. Good. Now question. I am using this counter or add. Okay, count up. For example, count up or you can use for add instruction. Okay, count up. This switch, you see, I will close this switch and that value is increment. This value is increment. 1, 2, 3, like that increment. This switch is closed. This switch is closed for every 500 millisecond. Every 500 millisecond. This switch is every 500 millisecond. Then this count value is increased for every 500 millisecond. One increment. Understood or not? One increment. Then that value, this value I stored. Okay, this value I stored in this particular memory location. MW4, I store it. MW4, I have to be very careful. This is my counter instruction. This counter instruction will be increased for every 500 millisecond. Then count up. This count value I stored in MW4. Then what will happen for this particular bit? M5.0, what will happen? Tell me. M5.0, what will happen? Anybody is having idea? Any idea? Sridhar typing. Very good. Whether correct or wrong, no issue. Just to tell the idea. Count will be 0. Okay, 0. First initially 0. Okay, initially 0. After 500 second, 1. Then after 500 second, 0. Very good. That is the blinking. You see, that is the blinking output. You see, once you can start this operation, then first bit means from least significant bit, right? This is the most significant bit. MSB, this is the least significant bit. LSB, right? LSB. This least significant bit, every 500 millisecond, on and off. It will be goes to like this. Understood or not? That means 500 millisecond on and 500 millisecond off. Then 500 millisecond on. Then 500 millisecond off. One cycle is 1 second. Right? 1 second. One cycle is 1 second. Got it or not? Understood or not? Yes or no? Then this bit address is M M5.0. M5.0. Got it? Then what is the function of M5.1? Tell me. M5.1. What will happen? Now easily you got idea. M5.1. Tell me. M5.1. What will happen? Every time. No. Every 500 millisecond on and off for this 5.0, this bit only, this bit. Last bit. Next bit. Very good. Every 1000 millisecond. That means every 1 second increment. I hope you understood. Yes, that is a technique. Once you understand this process, the memory concept is 100% is clear. Okay, this is mandatory for the Siemens controller. Better, I think. You have to always remember this programming. This is one technique for understanding the memory concept. Siemens step 7 memory concept. Okay, so that's why I'm putting to here. Okay, some of the people, they are interested in the Siemens controller, right? So that is mandatory. A little bit confusion maybe is there. So nothing is there. Actually, it's the memory data, how the data will be stored. Okay, so that is the thing you have to discuss. Even though if you are not able to understand, no issue, you can watch once again the video, easily got it. Okay, now you see this counter will be increment for every 1 second. This is a value. Okay, this entire value will be stored in this particular memory. That stored in the memory is in the by bit format, right? Bit format. That all 16 bit, right? That means last bit, okay, least significant bit will be on and off for every 500 millisecond. Next bit is on and off for every 1 second. Then next bit, tell me, M5.2, you tell me, please. 1 okay, 2 okay, every 2 seconds. Every 2 seconds. Next bit, every 4 seconds. That's all, sir. That's all. 2 seconds, 4 seconds, then next 8 seconds, right? 8 seconds, 16 seconds, 32 seconds, like that it will be go. So normally where to use this in section, you see this type of idea where to use means, for example, if you go to any boiler control or level controller or pressure controller, so if reaches to 80% of the temperature or 80% of the pressure, then the lamp will be blinking for every 1 second. That means it's going to be filled. Suppose if you go to above 90%, fast blink rate is needed. That means you go to the least significant bit, it will be generate very fast blinking. That's all. Suppose if you want a more blink rate, you can change the time for this particular one, that will be there. Only thing is here you can use for 2 power 0, 2 power 1, 2 power 2, 2 power 3, like that, end multiply with this particular time set point. 500 millisecond means 500 ms. Suppose 200 millisecond means 200 ms. That's all, sir. That's all. That's all. I hope you understood, everyone. So easily I explained. So some people may be little bit confused. You watch once again the video, easily you got idea. No problem. Okay, no problem. This is the only understanding purpose, right? So then tomorrow we'll go for the TAA software, and if possible I'll show the hardware, okay? Using TAA software, 1200 CPU, download and show to you. Then we can start the SCADA also. What is SCADA and how to interface, that also I'll tell you slowly. I hope you understood, right? Today I think little bit tough, I think. I hope if you understood, nothing is there. Some people may not from this background, may be confusion. Any doubts, sir? Any doubt? We'll stop now, I think. Better more than 1 hour is our mind also not able to cross, right? Grasping power is less. Okay, sir. Thank you so much. Thanks a lot. Any doubt, sir? Any doubt? Any doubt? Sir, step 7, admin CC. Yes. I'll set. I'll communicate. In CC. Okay, I'll type. Jayprasti typing. Okay. Any other doubt? Okay, sir. Thank you so much. Thanks a lot. You watch once again. I hope you understood. Okay. Then we'll go for another concept. Thank you so much. Okay. Good night. Good night. Good night. Tomorrow we'll meet again.